Okay, we're on to 3-5. We're talking about lines of best fit. Okay, so how do we get take a set of data and put a line on it that makes it, fit together? So here we are. Sorry, I lost my tab. Okay, here we go. So, for example, here is a data plot, right? It says Nicholas plotted data points to represent the relationship between screen size and cost of TV. So down here on the x-axis, so there's different sizes of the TV, right? 40 inches, 44 inches. And then these red dots represent the cost. So at a 40-inch TV is $300 versus a 48-inch TV is $475, right? So are there any trends? One trend I'm noticing is that the larger the screen size, the more expensive the TV, right? They're generally going up, okay? And it's kind of following a positive slope, right? Except it's not a completely straight line because you can see if I connected these, it would be zigzag. But it's almost there. So those are some things I'm noticing. So how can we take these data points and plot the best line? We've done a little bit of this way back in the beginning of the year when we were just guessing, right? We're trying to put a line in the same number of points are above and below. We're going to be doing the same type of thing, but we're going to use some tech. Okay, so here's some definitions. One definition is called positive association. What that means is when the y values get bigger as the x values get bigger. So for example, this is a positive association because the larger the screen size, the more it costs, right? This one's another example, right? The more hours that have passed after the sun have rised, the warmer it is. It's a positive association. Even though like here it stays pretty steady, right? Which makes sense because after 9 o'clock, even after 9 hours of the sun rising, maybe it's kind of maxed out. But overall, this trend is positive because mostly the more hours the sun has been out, it's mostly getting warmer. Then the opposite would be true for negative association, right? So now as the x gets bigger, the y value is actually falling. So one example would be hours after sunset. So now that the sun has gone down, the more hours after the sun has gone down, the colder the temperature gets, the cooler it is, right? And they're pretty much a similar definition as positive and negative slope, so it's easy to remember. So let's look at these. First one, is this a positive or negative association? Well, I'm noticing as x gets bigger, so does y. So this is a positive association. All right, what about this one? This one is all over the place, right? Here it's at 4, then it goes down to 3, but then also at 3, it's 8. There's no pattern here. So we would say this one has no association. What about this one? Here are my x's. They're getting larger. As my x's get larger, what happens to my y's? It goes 10, 8, 9, then it goes back up to 10 and then 6 again. But it's mostly going down. So this 10 is kind of an outlier. It's the one that doesn't match. But you could say that this is generally a negative association. Let's keep going. So this is what we did at the beginning of 8th grade, beginning of the year. We made these trend lines, right? We tried really hard to put lines in between all of our data points so it fit it really well. A trend line models the data in a scatter plot by showing the general direction of the data, and it fits the data as closely as possible. It may or may not pass through given data points, but should have about as many points above the line as it does below the line, right? We've talked about this. And so this one, it says electric hybrid cars sold. So years in 2000. So this would be like 2000, 2004, 2008. So as the number of years increases, right? Like bigger the year, the more cars that are sold, because this is the number in thousands of cars sold. So for example, here in 2002, this says that 50,000 cars were sold, right? So this has a positive association. And another word you could use for this is positive correlation, right? Because it's positively correlated that the number of years that have passed since 2000, the more cars have been sold. So what's the slope of this trend line? How could we find the slope of this? Well, you'd find it just like you found any other slope, right? So I know 2 points here. I know this is my x1 or x2, y2, and this is my x1, y1. So for my slope, I can just set it up. It's going to be 500 minus 50 over 16 minus 2, right? And so what is my slope? My slope is 450 over 8. And I have a feeling 450 can be divided by 8. My calculator over there. Let's just do it on my, they're both even, so I'm thinking it might work out. So 450 divided by 8 ends up being 56.25, right? So it's 56 and 1/4. So we could leave it like that. You could write it like this if you wanted to leave it in decimal. But what does that mean? I know I could at least divide it by 2, right, to get 225 over 4. So that might be the most simplified form I can get it, because I know I can't divide that by 2. But what does that mean? That means that my slope is, every year that goes by, about 56.25 thousand more cars are sold, right? That's what this number means. So my equation would actually be, we're going to write it like this time. We're going to write our slope in this decimal. Why? Because it's actually more helpful in this context. 56.25x, and then what's our y-intercept? We don't have a y-intercept, right? It's actually going to be somewhere down here. So how could we find that, right? Well, we could plug in what we know. So we can use this point. Let's use this 250. So I could say that 50 equals 56.25. And then my x is 2, right? Times 2 plus b. So we're solving for b. So this ends up 50 equals, well, what's 56.25 times 2? That is 112.50. 112.50 plus b. So now all I need to do to solve for b is subtract 112.50 from each side. So I end up knowing that b is negative, it's going to be 62.5.50. So I can come back and finish my equation as this. Right, so that's the equation of that blue line there. Every year, it's 56.25 thousand more cars are being sold. And this one, you could argue this is the best fit line, but in reality, if I was looking at 2000, we're really negative 62.5 thousand cars sold in 2000. No, it would either be 0 or something larger, right? So you would think, you have to think about, well, what's the problem here asking me, and does it make sense? Not for the year 2000, it doesn't, but for the other years, it does. This line, this blue line, is a good predictor of how many cars are sold, right? Because I could read right off of it. I could say, oh, in 2006, which is right here, I can tell you that, I don't know what this is, 175,000 cars were sold, maybe. So I could do that by using the graph, or I could plug in 2006 here, which would be plugging in 6, and see what the actual value is. Those are the different ways you can do it. Let's try some. The table shows the amount of time required to download a 100 megabyte file for various internet speeds, right? Okay, well, I'm expecting the faster the internet, the less time it's going to take you. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? So they gave us this. So you get to use Desmos to graph. So I'm going to come over here, use Desmos. We're going to insert a table. We're going to plug all this in, 35, 40, all the way to 60, right? 35, 40, 45, 55, 50, 55, 60. And then in my other column, I have 6.65, 5.82, 5.17, 4.65, and then I have 4.23 and 3.88. Okay, so let's find those points. Zoom out till we see them. There they are. Oh, so I'm looking at this and it looks like a negative association, right? These green points are going down as I go along the x-axis. So here is this really cool thing you can do to find the best fit line on Desmos. You would just type your y and you type this squiggly line, which for me is above my tab. And actually what I forgot, you see how this is a y1? I have to put a sub 1 there. Y sub 1. Then the squiggly line. And now I'm just going to put in slope-intercept form. M times x, but my table says x sub 1, so I need x sub 1. Then what's left from my y-intercept plus, or my y-intercept form is plus, slope-intercept form is plus b. So I've just typed this there. And guess what it does? It puts in the best fit line for me. There it is. It's already figured it out, that black line, and it's given me the equation here. It says that m is down here, negative 0.109371, and it tells me my b, my slope-intercept, is 10.2618. So I can take all of this off of here and use that for the equation of my line. So when I come back, I'm just going to write down what it told me. It said that the best equation was y equals, and then for m it said negative 0.109371. And then x. And then my y-intercept, the b it gave me was 10.2618. So plus 10 point, I'm going to just go a little crooked so I don't want to space, 2618. So there's the equation of the line. So what does that mean? That means that every extra kilobyte of speed I have, right? The time it takes me to download 100 megabytes decreases by 0.109371 minutes. Okay. So now it says use the equation of the trend line to solve the problem. Okay. So they want me to find how long it would take to download a 100 megabyte file if the speed is 75 kilobytes per second. So if I plugged in a 75 over here, what would be the time? Okay. Well, this 35, 40, 45, 55, 60 is the x value, right? If I come look at my table, that was an x. So now all I'm doing is using my equation and plugging in that x equals 75. So I'm just doing this, y equals, and just type it. What I'm really doing is y equals negative 0.109371 times 75, because that's my x, and plus 10.2618, right? I'm just typing all of that in. And when I go to my calculator to type that in, so what is negative 1.09371 times 75, all of that being added to, what was it? 10.2618. Well, that ends up being 2.058975. So I'm just going to round that off to 2.06. So what I'm going to come over here and do is just type, that's about 2.06. So what does that mean? If I were to download this 100 megabyte file and my internet speed was 75 kilobytes per second, it would take me 2.06 minutes. Which makes sense because it's decreasing, right? It's going to take less time the faster my internet is, which is the case that's going this way, negative association. The other way that you can solve for that, so this one told me to use the equation, so that's what I did. But if I wanted to solve for that quickly, the other thing you can do is use your graph, right? And you can actually come over to, and the way that I find this helpful is I'm going to say, oh, what if x equals 75? X equals 75, where does it cross my trend line? It crosses it right here, and it's 2.059, and you can see that's really close to the 2.06 we got. So you can use a graph or you can use the equation. It depends on the tools you have. Okay, so this is what you're going to do today. This is your task. We're going to see, this is why you had to measure for homework, your arm span, how long your arm span was in centimeters from tip to tip, right? If you hold it straight out, like your wingspan if you had wings, and your height. And you're going to create a line of best fit. Okay, so this means you're going to have to get the data from your classmates. You're going to have to gather everyone's arm span and everyone's height. You're going to record that. And then you're going to put that in Desmos and work on creating your line of best fit. And then we're going to explain what that graph tells us, right? Is there any correlation, any association between height and arm span, or no, right? That's what we're going to investigate today. All right, I'll see you guys next time. Bye.